Let's move on to the wait. Now we're done with that one. Factors affecting climate. So next is the ocean currents. So warm currents bring heat to coastal areas while cold currents cool them down. For example, Western Europe has milder climate compared to other regions at similar latitudes because of the Gulf Stream. Next is the distance from large bodies of water. So, water heats and cools more slowly than land. So, moderating temperatures in coastal regions, inland areas often experience more extreme temperature fluctuations. Example, coastal cities like San Francisco have milder, more stable temperatures than inland cities like Sacramento. Next is topography. So mountains can block winds and rainfall, creating dry areas called rain shadow on their leeward side. So for example, the Himalayas significantly affect the monsoon patterns in South Asia, leading to very wet conditions on other side and arid condition naman on the other side. So all these factors work in tandem, shaping local and regional climates in complex ways. Now let's move on to the climate zones of the world. So scientists categorize Earth's climates into major zones based on temperature, precipitation, and vegetation. While there are many classification systems, one common approach outlines five major climate zones. First is tropical. So they are found near the equator and characterized by high temperatures and heavy rainfall. For example, the Southeast Asia or the Amazon basin. So for example, the Amazon rainforest receives over 2,000 millimeters of rain annually, creating lush, dense vegetation. Next is dry, so very low rainfall and extreme temperature, like Sahara Desert. So, kuan, um, they can be hot like typical deserts or cold like the Gobi Desert. So the Sahara in the North Africa can go months without significantly rainfall, and daytime temperature can exceed over 40 degrees Celsius or 104 Fahrenheit. Next is temperate. So moderate temperature can distinct seasonal changes like spring, summer, autumn, and winter. So, much of the Western Europe and parts of the United States have four distinct seasons, so each with varying with temperatures and precipitation patterns. Next is continental. So warm summers and cold winters mostly found in inland areas of the large continents. For example, the Eastern Europe and parts of the North America. So have hot summers and harsh snowy winters. Next is polar. So polar is extremely cold with little precipitation like the Antarctica or the Arctic. So the Antarctica interior can see temperatures as low as negative 80 degrees Celsius or 112 yeah, negative 112 Fahrenheit, and snowfall is very minimal, making it one of the driest places on Earth. So these zones helps us understand the broad patterns of climate around the globe. However, microclimates can exist within these zones. Small areas with unique conditions due to local geography or human activity. So next, let's move on to um, the pressing issues today, which is climate change. So let's break it down. So first is the natural causes. So historically, Earth's climate has changed due to volcanic eruptions, changes in solar radiations, and natural cycles like the ice ages. So, example, the medieval warm period, roughly about 900 to 1300 AD, and the Little Ice Age, around 1300 to 1850 AD, were partly driven by natural variations in solar output and volcanic activity. Next, human causes. So, first is the greenhouse gas emission. We humans frequently burning fossil fuels such as coals, oils, natural gas, and also the deforestation as well. And the industrial processes release carbon dioxide, methane, and other gases that trap heat in the atmosphere. So, example, since the Industrial Revolution, the carbon dioxide concentrations in the atmosphere have increased dramatically, correlating with a rise in global average temperatures. Next is evidence of climate change. Um, Rising global temperatures, melting polar ice caps and glaciers, rising sea level, and increase in extreme weather events like heat waves, intense hurricanes. For example, the satellite data shows that the Arctic ice cap has been shrinking in extent over the last few decades, leading to habitat changes for polar bears and other Arctic species. And the impacts of climate change can really affect with our agriculture, um, because it can shift the growing season and also our water supplies, ecosystems like species migration or extinction, and human health like heat stress or kuan, spread of the other heat related diseases. For example, the prolonged drought in parts of the Africa had led had led had led to crop failures and food shortages, illustrating how climate shifts and have humanitarian consequences. So, the science is clear. So, while climate does change naturally, human activities has accelerated this process at an unprecedented rate. So our challenge is to understand these changes and respond effectively. So next, to study climate, scientists rely on the tools and methods used in climatology. So first is weather stations. So weather stations measure temperature, humidity, wind speed, and air pressure at ground level. Data from thousands of stations worldwide helps us track local weather conditions, which contribute to broader climate data sets. For example, the National Weather Service in the US maintains a network of stations that fed data into a central database, allowing climatologists to observe nationwide patterns. Next is satellite. So, satellite provides global coverage of Earth's atmosphere. oceans, and land surfaces. So they tracked cloud cover, sea surface temperatures, and even changes in ice cap. So, for example, the NASA's Aqua Antera satellite monitor. It monitors the our um, Earth's water cycle and yeah, Earth's water cycle and energy balance, providing crucial data on climate trends. Next is climate models. So computers simulation that predict future climate changes based on current data and that use mathematical formulas to represent the interactions of the atmosphere, oceans, lands, and surfaces, and ice. So models predict future climate changes based on current data and different greenhouse gas emission scenarios. So, for example, the Intergovernmental Panel on Climate Change, or the IPCC, uses multiple climate models to project global temperatures in rising sea levels and changes in precipitation patterns. Next is, so I forgot to add the historical and proxy data, no? So climatologists also study ice cores, tree rings, um, coral reefs, and sediments layer to understand past climates. So this natural archives can reveal temperature and carbon dioxide levels going back thousands of years. So, for example, the ice core examples from the Antarctica have shown a clear correlation between atmospheric carbon dioxide levels and temperature over the past 800,000 years ago. So, by combining direct measurements, satellite observation, and climate models, scientists can piece together a comprehensive picture of our planet's climate, past and future. I know, past, present, and future. So, next, the solutions and yeah, sorry, the impact on climate on the impact of climate and human activity. So, climate profoundly influences our daily lives, economics, and societies. So, these are some key points in it. So, first is agriculture. So, weather patterns affect growth, crop growth, harvest season, and livestock. So, changing rainfall and temperature patterns can affect or can cause droughts or floods leading to crop failure. So, for example, the regions like the California Central Valley, it prolonged drought can devastate the agriculture sector, leading to reduced yields and economic losses. Next is in kuan, infrastructure. So, extreme weather events like stronger hurricanes, floods, and heat waves can damage roads, bridges, and buildings. So, coastal areas face threats from sea level rise. For example, the Hurricane Katrina in 2005, or the um, it caused massive infrastructure damage in the New Orleans, highlighting how vulnerable certain regions are to extreme weather, and also the typhoon Yolanda in the Philippines. So next is health. So health is, if the higher the temperature can increase the spread of diseases and causes heat-related illness. So heat waves can increase the risk of uh, health-related illness. So changes in temperature and precipitation can also influence the spread of the vector-borne diseases, the malaria, and also or the dengue fever. So example in parts of Europe, and unusually intense heat waves heat heat waves have led to thousands of heat related deaths, stressing the need for adaptation measures like cooling centers. And also, I forgot to add the economic and social systems. So, fluctuations in climate can affect energy usage, tourism, and even political stability. So, example, a decrease in snowfall um, in ski resorts or areas can lead to economic downturns for communities reliant on winter tourism. So, understanding this impact can helps can help us to plan better, from designing climate resilient infrastructure to developing more sustainable agricultural practices so societies can adapt to or mitigate the effects on climate change. Now let's shift to more hopeful note. So what can we do about climate change? Solution and mitigation strategies. So first is we can switch to renewable energy resources like solar panels, wind, hydro, and geothermal power produce electricity without emitting large amount of greenhouse gases. And also, next is reforestation. So planting trees really helps us absorb the carbon dioxide from the atmosphere. Preserving existing forests is just as crucial. So, for example, programs in the Amazon rainforest aim to restore deforested areas by replanting native species to help reestablish carbon sinks and protects biodiversity. And also energy efficiency, which will improve the efficiency of the buildings, transportation, and industry can reduce energy consumption and emission. For example, using LED lighting, better insulation, and energy efficient appliances can significantly lower household energy bills and carbon footprints. And also, um, wait, yeah, and also sustainable transportation. So encouraging public transport, carpooling, electric vehicles, and cycling reduces emissions from personal cars. Like cities like Amsterdam are famous for their bike-friendly infrastructure, helping to reduce traffic congestion and air pollution. So by combining this technological innovation, policy reforms, and individual lifestyle changes, we can slow down the pace of climate change and adapt to its impact. It requires global cooperation and local action, but the benefits to our health, environment, and economies are well worth the effort. So, we've covered a lot of ground today, from the basics of climatology to the factor that shape climate, major climate zones, and urgent issue of climate change. We also explored the tools scientists use, the impacts of climate on human activity, and some potential solutions and mitigation strategies. So, thank you for your attention, and I hope this presentation has shed light on the importance of understanding our climate, both remarkable natural processes at work and the ways we can make a positive difference. So, again, thank you for joining me in exploring the fascinating and crucial field of climatology. Thank you, everyone. Have a good day.